So what he does, he invents a status of growth theory that doesn't exist. It's a fantasy. Right? Growth theory at the time is perfectly able to, one, model persistent growth in income per capita. Solo footnote 6, Koopmans, von Neumann, there is 30 years of literature, 40 years of literature, 50 years of literature, in fact, by 86, right? Because von Neumann paper is 1934, 36, something like that. Yeah, so it's half a century since people have proved the basic theorem, and there are millions of variations of that. So it's perfectly obvious how you do accumulation and persistent growth with a fixed technology. Not only, as it's very easy, if the issue is technological change and accumulating knowledge, to take the basic CES and treat it like that. Do you understand? It's really not very difficult to do this. Aggregate output is obtained with an aggregate production function like that. We all use that, right? Where there are n factors of production. Okay? And of these factors of production, from index 1 to m, they are non-reproducible. And from index I equal m plus 1 to n, they're reproducible. Okay? So these, we can assume they grow exogenously, or we can assume for simplicity they're fixed. From x1 to xm, they're fixed quantities. Labor, natural resources, the Mount Himalaya, the amount of water in the Pacific Ocean, whatever you want, right? Let's pretend it's all fixed. This grows like this. Right? And total output is aggregate consumption plus this. This is just to make the model simple and have one aggregate production function. If you want to make it sophisticated, because you say, look, buildings have a different technology from machines, and then there is machine of type 1 and machine of type 2, and then there are airplanes, and then there are ships, and it's very important that they have different factor composition. Fine. You write an n-sector growth model, any of the many available at the time, okay? It doesn't really matter, okay? It's just your algebra is going to become more complicated. Obviously, because of that, it's going to become much richer. They're going to have very different balanced growth, and small changes in parameters are going to make economies very different, right? And you can get your growth. And one of them, or two or three, could be PhDs in physics, master in mathematics, engineers, electronic engineer, blah, 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 right? Accumulated knowledge, right? The model is there. It's been available for half a century. When I say that the so-called new growth theory is one of the worst waste of time and intellectual frauds of the last half century, I'm not kidding. This was available and on the table. I studied in class Ian. I didn't even have to go to Rochester to learn it from Lionel Mackenzie. That was something that was even, Pasinetti, and not my hero, but even Pasinetti in the lecture in the theory of production has that. And so, actually, Pasinetti, if you take away the blah, 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 and the fact that they are not understanding that they're just studying a very special case of this, a very special case of the dynamic general equilibrium model. The lectures in the theory of production, I recommend you read them if you find them, because they're very nice, detailed, careful explanation of how basically a simple version of the von Neumann model works. Okay? So in case you have doubts with your algebra, in case you want to train yourself better in the details of those models, Lectures in the Theory of Production by Fasinetti is a good textbook. Okay? The second part, he wastes his time trying to prove things that can be proved in 3 lines are not very interesting, but that's the basic pedagogical thing I recommend. It's very well written out. Okay? Maybe it's a bit primitive in terms of notation. You could use algebra, matrix algebra, vectors more efficiently and save pages. But for a student at the beginning, it's maybe useful to have everything written down without much abstraction. So if you have a chance, take a look. Point is, this is there. Right? So now let's try to understand instead what is the exercise done in the paper. What is the exercise done in the actual paper? So first of all, the paper doesn't make much sense because it's trying to solve a problem that has already a solution. Very simple, very elegant, and old. But here's what the model does. The model says incorrectly, so the fact that it says it's accumulated knowledge, it's irrelevant. Obviously, yeah, obviously it has to be something accumulated, and it's clear from Muzawa, from all the papers before, that knowledge is one of the things you can actually reproduce and accumulate. By the way, because it's embodied. Please make a note of this. Next week or next class, I'm going to go back. There are 2 things we said today that I said make a note. One is the way we treat TFP and the way we think of it. There is the idea of technological progress as a set of disembodied blueprints. That's TFP, right? This thing floating in the space that it has nothing to do with him being different from him or her, nor it has to do with this laptop being different from that laptop, different from the old mainframe. It's not embodied in machines or human. It's disembodied, right? Okay. So let's keep these 2 things in mind because they're actually going to be fairly relevant, I believe, to understand some of the open issues from my point of view in the theory of growth and innovation. Okay, we'll set them aside. All right. So what is that the Roman paper does? So creates a problem that doesn't exist. Fine. Then says I have a solution. The solution is that there is knowledge that is accumulated, and it says it leads to increasing returns. In fact, if you read the paper carefully, it pretty much says that without increasing returns, you cannot get persistent growth. And this is actually a strange idea, funny idea that people had for many years. Right? Now, I understand what is the decreasing return means. In the aggregate, it means that your production function has somewhat of a shape like this. Okay? At least locally. Now, by the way, it's a bit complicated. Like global increasing return is a strange animal, right? What does it mean to have a technology with global increasing return? I don't understand. As Solo correctly pointed out in an ironic paper, John Economic Perspective, it means not only we're going to become infinitely rich, we're going to become infinitely rich, infinitely fast. That's nonsense, okay? So I don't know what global increasing return, you know, in what sense one can think of technologies out there in the aggregate, at which level of abstraction one could imagine that it's reasonable to think, oh, there are global increasing return, right? But even locally, if it is relevant, increasing return have a problem for economics. They are not amenable to any form of competitive equilibrium with more than 1/3, right? If in the same market for the same good, the technology displays increasing return, one of us will have to come and dominate the market. And we will not be able to price at marginal cost this standard IO result. So you can't do competitive equilibrium with that. Now notice there is another, in my opinion, the reason why people got fascinated in this literature for a long time with increased return was actually not this absurdity that you need increasing return to have persistent growth. It was the fact that you get that. And if you don't think hard, and you think only to this kind of thing, makes you think, oh, look, I have a poverty trap here where I remain poor. And here instead, I have a threshold that if I stay on the right, I grow forever. And if one doesn't look at the data carefully and doesn't look at history carefully, one may get convinced that there is a sense out there in which the history of the world may be interpreted as a matter of poverty traps. Right? And so this seems to be an attractive way of modeling it. Oh, if you start very poor, you always remain poor. Notice that that's why actually everybody in Washington loves that stuff. Because it gives you a beautiful theoretical justification for policy intervention anywhere. Just donate money, just go spend money everywhere. Now, it's very funny, this thing of the poverty trap, because think about it. So maybe there is a poverty trap. I mean, here in Italy, we hear the story about poverty trap about the South. The South is always below the threshold. Funny enough, income per capita in the South right now is about twice what it was in Milan in 1950. And apparently Milan could grow. So this thing of the poverty trap is very relative, huh? Isn't that funny? Well, but then if it is relative, then it can't work with a production function, right? One has to take models seriously. You can't use models like taxis. You get in, then you get out, then you get in. I'll walk a bit. No, I take a bike. No, I need a cab. Oh, no, I'll take a train. You know, not like that. Right? Oh, I'm swimming, actually. I don't need a cab. Thank you. Doesn't work like that. So this thing of the poverty trap is one of the biggest bullshit we have ever invented as economists to justify bad policy. Because if you think of the history of the world, there is not such a thing as a poverty trap. They were very poor 5,000 years ago, all of them. They were so damn poor, it was ridiculous. They did not have a roof, they did not have electricity, they did not have protein, their height was 150 because they couldn't eat meat. They were weak, the expected life was 40 at birth. Even Caesar was a weak crap compared to any athletic guy of the day, right? They were very poor. Well, they grew. So in what sense is there a poverty trap? So if one has a theory of poverty trap, the only acceptable theory of poverty trap that are at least logically coherent, not that they're satisfactory, but if you really want to claim that there are poverty traps in the sense that at any given point in time, there's a level of income and education and so on that makes it impossible for you to grow, it has to be some Marxist redistributional conflict, which is between you and I. You're so much at advantage with me that any tentative I make to invest, to improve, you extract the surplus from me and you push me back. I'm happy to consider that. I think that in certain instances it matters. If I want to understand colonial power, if I want to understand instances of domination, I think it's relevant. I think, for example, it explains a lot of colonial rebellion, including the American colonies, because of this, right? That the imperial attitude is often to say, keep it at bay, extract the surplus, make it impossible for them to grow, right? Because that's what allows us to control and exploit. So I'm willing to consider that, but to think of that as the reason why Calabria is poor, or Zimbabwe is poor, or the interior of Brazil is poor, seems nonsense in the light of what we have observed. They were dirt poor in South Korea in 1952. They were dirt poor here. They had pellagra, right? They lived in houses without, in Veneto in 1948, they lived in houses without heating. All they eat was polenta. You know, they had no education, blah, blah, blah. The income per capita was equal to Sicily. So the examples are infinite. But I think lots of people have that in mind. Right? Because when you have a poverty trap argument, then obviously there is only one way you can take this individual out here, and it is to provide them with transfer, with donation, with public intervention, with the World Bank going to the local African dictator and cutting a deal. You know, we give you a few billions, you treat us properly, right? So I think that that was part of the success in the late 80s and all 90s, this emphasis on that. And which, if you look at the literature, led nowhere. There's a beautiful book, actually, I like it, and it's good that it changed his mind. Bill Easterly, who actually worked at the World Bank. The book is a bit ironic, but he has, what's the name of the book? You check it out. You know, as you have learned by now, I'm Mr. Alzheimer. I tend to forget names and titles. So Bill Easterly, he has written a bunch of books. He's written another one recently, The White Man Burden, which is less, I think, interesting than the old one. The old one about growth, it is his first book, it was quite successful, it's very nice. It's divided in two parts, and it has limits. The second part is a bit ironic, but you should read it. The first part is very nice. It takes apart, it says it tears apart most World Bank, IMF, IDB, and so on, United Nations policies in underdeveloped countries, showing that behind all these gigantic transfer, there were bad models, bad arguments, and incredibly bad mismanagement that has produced nothing really useful. Now, the second part is a bit ironic because he seems to be convincing himself that he's now discovered the light and the truth, and he's going to solve everything. But that's a bunch of theories. The facts he reports in the first part of the book are worthless. So that's one of the arguments. But in fact, what Romer does very simply is actually a sequence of tricks. He says, I am not going to model knowledge, but I pretend it's capital. Then I'm going to write a production function for my firm, which is a standard production function, right? Plus, there is an externality, right? The externality is created by the aggregate capital stock. Okay? There is a continuous firm. That's the next thing. And I'm going to assume that given the aggregate capital stock, this production function, the firm production function, has decreased your return to scale. Okay? You follow me? If you've read the paper, and then what is that I do? Well, I normalize, I fix labor, and what I do is a very simple fixed point argument, because I can take the aggregate capital stocks parametrically. I can have every individual choose their own capital stock parametrically. So this becomes a standard Euler equation, only it's parametric on the aggregate. And then I say, well, let's assume for simplicity all firms are identical. So the aggregate capital stock becomes the average capital stock, which becomes the capital stock for everybody. And so I boil down everything to one variable, which is the average capital stock. Right? And then I have to solve that perturbed Euler equation. Interestingly, in the paper, he's not able to solve it. Right? If you read it, all he can do is say, well, there is an interval of solution. Actually, we solved it a few years later with Aldo Rusticchini. If you're interested in the technical things, Aldo and I worked out that model and other completely, providing the solution is not that difficult. But that's not the point. I don't want to get into the technical thing. I want to get into the substantive things. What is it you can prove at that point? So what is it you can prove in terms of explanatory power of the model once you've gone through all these songs and dances? Exactly the same thing you can prove in the Kaas-Koopman-Solo model. Why? Because you prove that there is a unique balanced growth path to which the economy converges asymptotically, and it converges from above or from below, depending on starting with too much capital labor ratio or too little capital labor ratio. So if you start with too little capital labor ratio, you converge, you grow very fast, and then you slow down, right? And that's the path. That is, if you look, right, so you have kind of two ideal set of economies. One is Kaas-Koopman-Solo. There is balanced growth, driven, say, by TFP, or there is balanced growth because of CS, constant return to scale, either one of the two examples. Notice that the two examples are also non-distinguishable, right? Because in both cases that you call it TFP or you don't, you have growth at a constant rate in income per capita. The only difference is in the CS story, it is because the reproducible factor get accumulated. So in case you can measure them, you measure them. And in the TFP cases, no, they don't get accumulated. There is this magical thing happening. But from the point of view of Y, Y per capita, it just grows at a constant rate. So that's one word, and that word, you converge to that balanced growth path from a high-speed thing, right? Because I'm sure you can do it with the CS I gave you as an homework, with a production function like this, that converges to that, you start out growing fast, and then you slow down. No? And eventually you grow, it's the solo example, right? That's a solo example, right? You converge to the AK, the old literature of AK in 1990. This is footnote 6 in 1956, okay? And they all talk about AK. So this is, you converge to the A, but at the beginning you have this thing, and this thing is relevant. So it makes you grow faster. As it exhausts its effect, you just grow at A, right? So, convergence from fast growth. Which, interesting, is what we have observed. So while the story in the model may not be right, because it's not purely due to capital accumulation, the metaphor works, right? The metaphor works. Well, what is it this model does with the external? Well, the same. And the intuition, is very simple and it's almost obvious, right? Think about it. The intuition is you can have all the externalities you want. Doesn't matter if you want to assume. It's unclear why you want to assume externality. We should debate that next class. Think about the externalities, please. Positive externalities in production. Try thinking about it, because I want to try to pick your brain. Maybe there is a thesis to be written there. Why we observe out there a lot of negative externalities, but not a lot of positive externalities. We'll talk about that first. But anyhow, what is it this does? At the end, you may have increasing return, but for the reason Solo pointed out, you technically, in a model that is aggregate, one reproducible factor, because the Romer model boils down to a model with one reproducible factor, right? This being called capital, right? Eventually, your production function has to become linear. It doesn't really matter what's driving it, because if your production function doesn't become linear, for Christ's sake, it's going to go like that. It's going to do reach infinitely fast. But then your discounted sum of utility is now bounded. You remember what I taught you, I think, the first class or the second, right? The transversality condition has to hold for the individual optimization. And if I'm growing very fast, I'm blowing it up. Well, so eventually I have to start growing. My production function can be as crazy as you want. I can do all kinds of stuff. But eventually it has to become nearly linear. Among other things, because if it doesn't, I'm assuming that average productivity is going to infinity, which is a crazy assumption. In fact, what we show with Aldo is that it's enough to assume that average productivity has an upper bound. Notice, an average productivity has an upper bound. That's all. Okay? And then you get linearity. But if you get linearity, then of the two ones, either it's always linear, extreme case, okay? Either it's always linear, then it's AK. Or you have to land on it from above because you're growing fast at the beginning, you have little capital. That's it. You end up having a unique balanced growth path to which you converge exactly like in the standard CS model. No, the two models are completely unobservable, undistinguishable from an observational point of view. They both predict poor countries, little capital, you grow fast at the beginning, then you slow down, and at best, you converge to balanced growth. End of story. That's it. Okay? All right.